let's take a similar look at Apple's CarPlay. Again, we'll touch upon its history, look at the system elements, briefly talk about apps as well and app requirements. So really CarPlay, you can consider having its roots in what was iPod Out, which was a joint venture between Apple and BMW. And so the first vehicles were, not surprisingly, in BMW Group vehicles in early 2011. And from then on, CarPlay updates worked with the iOS updates. So you can see just a few of the major updates here with iOS 9 introducing wireless CarPlay, 10 added messages, 12 adding turn-by-turn guidance. And then with iOS 13, there was added the split layout, start mode, and support a third-party app. Then iOS 14 introduced wallpapers, EV charging and parking location services, AppX, and gave apps access to the CarPlay framework to, again, give that consistent design. More recently as well, Apple Car Keys, which enables an iPhone to open a vehicle. Again, you probably see those latest features in BMW vehicles first. So looking at visuals here, Android Auto, if you remember, had 3. For Apple, we've got 4 supported screen resolutions. They're listed there from 800 by 480 through to a 1920 by 720 widescreen. It uses the San Francisco SF font, and it also incorporates coordinate system, which uses a scale factor. So for a standard resolution screen, you could have a 1-to-1 pixel mapping. So 1 pixel on the phone would map to 1 pixel on the car kit screen. But you could have, for example, 2 times scale factor. So your 100 by 100 pixel icon, your original would be a 200 by 200 pixel size on the car screen. But as CarPlay automatically scales, it's recommended icons are 200 by 200 pixels, and then the CarPlay will automatically scale that to the car kit screen. So it could scale it up or down. Looking at the system elements, again, we see the screen split into 3. There's access bar on the left with shortcut icons. It's got the time, connectivity status, and a home button. And then the main part is the main window where you show lists, map views, etc. And then the top part could be used either for a navigation bar. So if you've got a table, you can see at the bottom picture there, that's a table or a list of playlists, or a tab bar, which is in the picture on the right, which has shortcut actions for the app. And it only displays 5. So if you've got more, then the right-hand side would be icon would be a more icon. But it's obviously recommended not to have those depths of navigation so as not to distract the driver. And here are some of the system elements which come across from iOS. So these system elements in CarPlay, first of these is action sheets. So that's similar to the notifications in Android Auto. They're alerts that'll normally slide up from the bottom of the screen, and they should be avoided. You then have activity indicators. So you could use, for example, a spinning icon, and use that so the user doesn't think that the CarPlay or the car kit is locked up, so they can see that something's happening even while something's buffering or loading, for example. Alerts, now these have a title, an optional message, and can have 1 or more buttons, but it's recommended that their use is limited. Next is buttons, which is what you'd expect. So you've got app-specific ones, such as play, skip, repeat, shuffle, but only Apple's system button style is supported in CarPlay. Then collections, which are ordered sets of content, and labels, which describe an interface element or provide a short message. You've got the navigation bar, which we touched upon, and the tab bar. And the tab bar, if you remember, allows you to switch between sections of an app. We'll just touch on some of the design recommendations. So looking at audio as an example, this includes a transition to the now playing screen once the content is ready to play. So buffering, for example, might mean a wait of a few seconds for the audio to appear, but the audio should start playing as soon as it's loaded enough data. And then information such as track metadata will load in the background and appear when it's available. Then you've got playback, shouldn't start automatically. And after an interruption, the audio should resume if it's a temporary interruption. That could be, for example, an incoming phone call, but not if it's a permanent interruption, such as a Siri-initiated playlist. And relative audio levels of the audio elements can be adjusted. So you can have different parts of the audio change it in volume relatively, but the overall volume shouldn't be adjusted. And the car kit itself should be used for short sounds such as alerts rather than them coming through the phone. So that's looking at audio, and then next moving on to messaging and VoIP recommendations. These should use Siri and be exclusively voice driven. They've obviously got to support reading and composing of messages. The user's got to explicitly opt in for those notifications to appear. And for VoIP, the appropriate Siri functions are enabled. For example, the ability to search through call history and start audio calls. So like Android Auto, CarPlay also supports custom apps and includes what's called Automaker apps for the OEM, so the car manufacturers themselves. That could include, for example, controlling the vehicle's climate control, GPS or radio stations. But if used, then the app's got to limit the controls and the content to what's relevant to the car. What you don't want to do is expose every feature. That'll make the app really complex and therefore less safe, because the driver would need to look at the screen for a longer time. And the idea, if you remember, is everything should just be glanceable. So only momentarily taking the eyes off the road. So it's got to use standard controls. A subset of the user interface controls are optimized for CarPlay. So we touched on those a little bit, the buttons, labels, nav bar, tab bars, and tables. And finally, shouldn't mimic the design of the car's native interface. It should still look and feel like you're still within the CarPlay app. Otherwise, that can produce fragmented and therefore confusing and even distracting user experience. So that's really touching on CarPlay and Android Auto. And the final section I want to do today is just have a real quick look at interop testing of phone projection and car kit combinations. So this is an area that Frontline Test Services offer. So why should we test? Firstly, to ensure basic functionality, i.e. it works. That for things like navigation, phone, audio, etc. Next, to ensure a good user experience and user interface. So it works as expected in all the common scenarios. That can include transitions between functions, such as receiving a call during navigation, and transitions between states, such as being in an active call when you plug the phone in and the phone projection is initiated. And finally, to ensure interoperability. So in other words, it works across all devices. So this is for all expected phone and car combination in that particular market that is getting launched. And also when there's other devices in place. So for example, you could have a smartwatch, a headset, and also to look a little bit deeper into coexistence with other technologies in the vehicle, such as if the car kit's got a Wi-Fi hotspot, and also interaction with I haven't put it here, but interaction with functionality within the vehicle itself. So for example, if you've got phone projection connected and you put the vehicle into reverse, parking sensors and the reverse camera should obviously take priority. So some example test areas to look at, basic testing would be connectivity. So that's connection and disconnection, and first connection versus reconnection, how that works for the user. Then interactions and inputs, so anything that the user does. And then what happens if something goes wrong? How are those error scenarios being handled? Again, you're not trying not to confuse the driver, and also you're trying to reduce calls to customer service, for example. Then once a device is launched into the marketplace, it's important to continue to test for multiple reasons, but a few of the main ones here. You're obviously going to get new phones launched into the market. There's going to be updates to phone operating systems, and there's going to be updates to the phone projection software itself. So for CarPlay, the updates are linked to the iOS, but in Android Auto, there's continuous updates, and these can appear across different phones at different times. So in the marketplace, you could have lots of different versions of Android Auto, for example. And what happens when Samsung, for example, updates their Android Auto on their phones, they roll that out, is that going to cause an issue in the field? We can also look at app testing. In the first stages, that might be just against a car kit simulator. So CarPlay has a CarPlay simulator, Android Auto has the Android Auto simulator, and MirrorLink has a MirrorLink client simulator. Then that would be followed up next by testing with real phones and against real vehicles. And if there's any issues, we want to debug the various layers. So USB, the Bluetooth, the Wi-Fi, and then the proprietary projection protocols as well. So Tim, I've just listed here a few examples of recent issues that we come across. They can include basic things like connectivity issues, so slow connections or failing to connect in the phone projection mode. So if a phone fails to connect maybe 1 in 1,000 times, that may seem like a very low failure rate, but over 100,000 vehicles, obviously that becomes a significant amount of customer service calls, costs, and reputation. And you can have user experience and user interface issues such as sluggish response or functionality issues, so functions not working correctly, audio issues resulting from user experiences, for example. Different music streaming apps may give a different experience or may have different issues. And finally, a couple more explicit issues. So Android Auto, when connecting via USB, the phone is obviously being charged by the USB cable as well. But in some cases, when the phone has become fully charged, so it's at 100%, stopped charging via the USB cable, then the phone projection is disconnected. And then also things like voice assistant issues, so voice activated calls sometimes have had no outgoing audio, so the mic's not working. And then when navigating via voice, getting a response like, I think you're trying to navigate, is that correct? Almost like a fall through error state. And then for CarPlay, so in iOS 14.5, for example, issues with music stuttering during playback or CarPlay freezing when switching apps, and then Siri stopping its announcement partway through reading a text, or even worse, when giving navigation directions. Again, all of these things can range from mildly irritating through to distracting and even dangerous, depending on the issue and how distracting it is to the driver. We covered what projection is, then went into a little bit more depth on the different elements, such as the display and the interaction. If you remember, the key mantra really for the safety is eyes on the road and hands on the wheel. So you're trying to keep the driver's eyes on the road. That's why you want the UI to be consistent and glanceable. So the driver should be able to get the information from the screen with just a glance. And then hands on the wheel. So again, touching as little as possible. And also the move, if you remember, through to voice. And then we delved slightly deeper into the CarPlay and Android Auto, which are the most popular phone projection technologies. And then finally covering interoperability, so approaches to testing and some example issues.